Hello everyone and welcome back to a new video in our robot structural analysis professional tutorials. This video is going to be a rather relaxing video as we are going to embark on an auditing journey. I will mention what this means in a moment. You can just relax and grab yourself a cup of coffee or tea or soda or whatever you like to drink and just enjoy the ride with me. In this video, I am going to audit, which means check and evaluate, a model submitted by one of our dear subscribers and check out what the problems are. Now, I will not do a full deep check for this model, but I will basically wear the hat of a senior engineer. If you are an engineer in general and you submit your model to your supervisor, how would you look at things? Now, of course, I'm not saying that this is exactly how the supervisor would look at your work, but let me just tell you some stuff that he would be looking at when he evaluates a model. And maybe you can learn some techniques how to resolve the issues and how to detect certain errors and adequately avoid them. So it's going to be a nice, easy going video. And with that being said, I hope you enjoy. So sit back, relax, and enjoy the show. Okay, so the first thing I usually do is I check out something called material definition, the section definition, and the load definitions. Now, I know for a fact that the loads have not been added yet. This is what my dear subscriber told me. You can only see self-weight, so there is another model where the loads are applied. But what I would do, the first check I would do is check out your assumptions. And by assumptions, I mean I would check out your loads, see if you have assumed loads correctly, see where you applied the loads, and also check out other assumptions such as materials and sections. Like I go to the sections, see what kind of sections you have. I could also, for example, just open the section to have a kind of look of what the sections are that you are using. And for example, I can just stop here and look. It's a 300 by 300 section. It's quite small. So I don't know. It's quite small because it seems to be a long column. So I'm kind of worried about the buckling here. Also, something else that kind of sparks immediately my interest is, I'm not sure, but I think this might be a retaining wall. Of course, here I'm doing a blind review, so I'm not really sure exactly what the model should represent. Oh no, I stand corrected. It's not a retaining wall because there is nothing here. Okay, fine. I'm still kind of worried about this column. I suspect that it might be a long column, 300 by 300 for this length. Might not be adequate, but well, it's of course something that you have to check with KLU over R and see. I mean, this one is really long. What's the thickness of this one? The thickness is, let's see, 0.3. Let's take a look on the thickness. You see, this is how I do my initial check. So that's the thickness, 0.300 millimeters. I'm not sure spots, 300 millimeters for this long thing. I am afraid for having buckling in the weak axis. This is 300 millimeters and the length is, I don't know. Let's see. Okay, let's go to tools. Dimension lines, take a look on the length, 60 meters with 300 millimeter. I don't know spots. I'm not really happy about it. But okay, I would immediately tell the engineer who submitted it, I would immediately advise him to check the buckling of this wall from the structure and the loads you have, because this load is not braced and I'm afraid of the weak axis buckling here. Similarly for those three walls. Is there anything else where buckling might be a factor? Yeah, this column is still something I'm worried about. Those seem to be fine. So yeah, I think the sections... Wait, is this a column just floating in midair? Oh, there is a column floating in midair. So I'm not happy about that section. I'm pretty sure that this beam will be under heavy torture from the given loads, because you have a column here, and the column carries obviously multiple stories. Oh boy, this, my dear friend, needs to be increased by a lot, because you have so much load on the cantilever. How long is this? Let's see. And you can see that this is how the video will go. It's going to be me speaking my mind. I know usually I'm more intense. My videos are more intense, where they zoom in, laser focused on a point. But this time I thought, hey, you know what? Let's just take it easy this time and just speak my mind. I don't know if this is the kind of videos you like to watch. Benefit of something. Let's take a look. It is 2 meters. Not that much, but still. I think that this section needs to be increased because you have a column that carries slabs on top of it. Oh my, this is not really good. So I check this cantilever. Okay, this is the same. My note stands on all those points. There is a beam floating here in midair. There is no column. Wait, what? Okay, there is no column. I'm kind of perplexed. There are some stories where the columns are not moving fully. So this one is not continuous. I don't know about that. doesn't seem right. What's the point of this, and why is it not continuing? Like, and what's the point of having it in the first place? So, okay, this is something that needs to be checked. Because if you need a column, you better continue it. If you can ignore the column, then just delete everywhere. I see, you need a column here. Okay, I see. I see the reason why. You need a column here for that edge, so this is needed. Okay, at least, can you continue it downwards? No, it seems. Okay, I kind of understand now where he's coming from. He comes from here. I don't know why you need the column all the way. You can just have it until here and have a big beam here. You can even, as a pro move, you can even make it inverted. So instead of dropping down, you can drop it upwards, if that's the thing. Fine, what else do we have? So there are some structural comments I have that need to be improved. Otherwise, I'm just looking very quickly here. Okay, now that's the first thing. I continue our section checks and check the material very quickly. I want to know exactly what he used. So is his material assumptions okay? Now, to be honest, I don't know exactly what available materials he has in his place. Well, that's another cantilever that needs to be strengthened because it's a column that is discontinuous. You see, look, whenever you have a column that is discontinuous, the beam that carries the column needs to be big. Let's check out the materials, have a look. Okay, he's using he's using concrete, and he's using C2025. That's quite the weak concrete. I don't know exactly what type of concrete is available. It depends on the region here. This is a regional setting. But of course, I would immediately comment here and say, remember, I don't know exactly what kind of regional settings he has. I can see French here, so maybe he is from a French region, but a French-speaking region. But 2025 is kind of too weak for a column. I would go for 30 megapascals with a column and 25 for slabs. But of course, by the way, this strength is only a suggestion. My suggestion to you when you want to define columns and beams is to have columns 25-30 at least, and beams 25-30 and slabs 25. And if you have a pre-stressed concrete slab, then you would at least go for 45 because you need the compressive stress to carry the compression from the tendons. There are checks that you need to do with minimum maximum stresses. Okay, sorry, I digress. Back to the point. I cannot say it's wrong, but I kind of had my reservations here. Okay, what about the supports? Did he support it well? Let's take a look. So he seems to have supported. Okay, he's not doing a raft. Okay, that's okay. He's not applying a raft foundation. Fine, no problem. Okay, so at least on the outside, there are some things I mentioned, but all in all, there are some things he needs to modify. Now, going back into the depth of it, I have another file where the loads are applied, but just from the get-go, I can see some, I call them mesh contaminations. I mean, look at this. This is an ugly mesh. And it's not because of Robot, it's because there are some problems in the model itself. For example, look at this here. Like, what is this? Something I don't understand is this one. Why is this poking out? This might be a mistake, or it might be intentional. What is carrying this thing? Because I can only see a beam all until here, which is kind of odd. Beams should go to the column. You see, I can sense Revit here. I can sense that this model is exported from Revit. And after I saw this model, I have now some encouragement to cover Revit in this channel. Because I think that this comes from, yeah, see, this contaminated mesh. Okay, so I can see some strange contamination here. Okay, why is this? Let me just remove the section. You see, whenever you see meshes like this is a warning sign for you immediately. This means you have misaligned bars or something. Allow me to show you. If I zoom in far enough, I think I can see it. Yeah, see? Now you can see it. Look, this is the ground, and those are the two walls. The two walls are misaligned with the ground, it seems. So yeah, this is why the mesh goes haywire here. Let's take a look on this one, for example. There is another mesh contamination. Those are the comments I would give immediately my dear engineer to double check. Yeah, see, yeah, this is contamination. You can see that those two things don't align perfectly. Wait, what? There's even a beam. Makes it worse even. Oh my God, this is even worse. If you have a beam like this would freak out the system. Okay, that's the reason why. So this one needs, I think this is everywhere, right? I think this is like, yeah, misalignment again. It's totally misaligned. This needs to be pulled on the corner. It still analyzes, of course, but the quality of analysis will be very, very low. Yeah, those are my immediate comments on the file. There is another contamination here. Let's take a look. If I zoom in enough, there's a column. Aha, okay, there's a column. The column is, wait, the column is outside? That, or is it inside? Do my eyes deceive me? I think, okay, I think I have it. If I zoom in enough, yeah, there we go. See? Yeah, there we go. There it is. This is the problem. This is the column. That's one plate, and that's another plate. It is an accuracy issue. I think this has been exported by Revit, and you have all those accuracy issues. I mean, look at this. This is not really good. This is the case because the column is misaligned with the edges of the wall. So let me show you. If you open the column, it's misaligned with the edges of the wall, and that's the reason why the wall tries desperately. You see, a robot is resilient. It tries its best to fix your model, despite the fact that your model is not good. Because that's the column, and that's the place where the two walls meet. So that's the reason why it struggles here. Okay, so at least the mesh anomalies have been spoken about. The reason why there are mesh anomalies is because of the modeling accuracy, especially in Revit. If you model in Revit, you see the problem is that I think I know what happened. I think what I know is he modeled the walls in Revit. In Revit, it looks perfectly fine. You will see that it aligns perfectly. Actually, I think I know exactly what happened. Let me show you. Right click, display. There was something about member thickness. Ah, there we go. Panel thickness. Yes. Apply and close. Yeah, there we go. This is exactly what he sees in Revit. I think I know exactly what happened. You model your structure in Revit, I think, and it looks perfectly fine. It looks very nice, and you can see all the edges seamlessly click in place. When you export this to Robot, problems break loose because in Robot, it doesn't consider the thickness of the wall. It actually only considers the center of the wall, and that's why I have the misalignments here. And it looks perfect. Like, look, it looks perfect from the outside. There is no misalignment at all. Like, it clicks so perfectly. But when you remove the thickness, then you can see that the problem immediately is shown. So that's a modeling issue from Robot to Revit. And that's the reason why I want to start, when I have time, I want to start a series about that. I mean, look, this is another contamination here. You can easily check. I'm pretty sure it's the same. See, same shenanigans. You have a column that is misaligned with the wall, that is misaligned with the beam. Like, look, if you open the sections, beam, sorry. You can see two beams which from the outside look perfect, but if you just remove the section, you can see that those two beams actually misalign, and Robot struggles in meshing that thing. Those are my comments on the mesh. Of course, the question is, how do we solve that? Remodeling, unfortunately. You would have to delete the plate that has a problem and remodel it again. One other thing I noticed about this model is that there are something called duplicate models or overlapping elements. I mean, if you go to analysis verification, it will even tell you how. And there is a very easy fix for this, by the way. Like, people freak out when they say overlapping members, beams, and so on. But it's actually really easy. To solve overlapping members, all you have to do is to click on the error. It will highlight it for you. And the cool thing is, it also highlights it here. So when you, let me just show you again. If you just click anywhere else and close this, okay? So how do you overcome overlapping elements? You go to analysis verification. Of course, it will verify and tell you there are overlapping model elements. And now it's time to solve that. So you don't see any selection here, by the way. If you click on overlapping members, beams, columns, and so on, you can see a big selection here. And if you Control-C it, I just Control-C and Control-V, those are the elements that have problems. Now, of course, the question becomes, which are the real elements that have problems? The detection is quite easy. I just have to go to my notepad here, and I'll start selecting one element by one element. So I'll just, for example, I will select those three, and Control-X them, Control-V them, and see, because overlapping elements means one element is obviously over the other element. So I selected 3, and those seems to be the big ones, so those are not the problem elements. I'll continue my selection. So for example, if I select this element and Control-C and Control-V, it will highlight the element, and it seems to be, yeah, see, this is the overlapping element. You can see that this is one of those. How do you know? Well, look, it basically highlighted this small element, but there is a big element from top to bottom. So this small element has no need here. Actually, the crazy thing is, when I hit the delete button, it seems this will not be deleted, but it actually gets deleted. You know why? Because look, if I stop here, you can see that this is element 238 and it spans the entire height of the structure. You can see it here. I mean, you can see that it spans from top to bottom, okay? The duplicate element is exactly on it, as you can see in the dark blue. So when I delete it, it will only delete the duplicate model and the element, and it will keep the real element in place. So you can see the duplicate has been deleted, but instead the original 238 is there. So that's how I can easily detect and delete duplicate elements. Just click on the error, copy this, paste it somewhere safe, and start investigating. So this is the first model I have from our dear subscriber. And this is the other one I have from him, which is quite interesting. It is very, very interesting. And he has centimeters. Why are they centimeters? Did I mess up my system? Let's go back to metric and okay. I still have centimeters here in displacement. Why is that? Let's say units and formats. Go to other. I like my displacement in millimeters. Thank you. 134. This is okay. First of all, let's take a look on the loads. Load table. And I can see loads applied, 2.5 and 5 in the dead. 5 in the dead. Oh, interesting. Okay. And 3 is somewhere. So there are loads applied. Okay, good. I would, of course, if I have knowledge of the system or the project, I would manually calculate the deflection. This looks pretty gross. See, that's the buckling thing I talked about. My fears were in place. Okay, so let's just remove this horror movie and just open the deflection again. And where is the issue? It seems everywhere, so let's investigate. Now, to investigate deflections, I will first of all go to Results, Maps, and ask it to open the UZ map. Because if the structure deflects, I cannot see anything. Actually, I can. Let me show you. You could go to Diagrams for Members, go to the deformation, and just, I don't know, normalize the deformation. And does it work? Yeah, it does work. Maybe reduce the scale of the deformation. And it's pretty obvious. Okay, see? Now, this is how you do a deflection evaluation. You do deflection evaluation by looking where the problem places are. There is one problem place. This is because of the, I can only say I called it. This is because of the stiffness of the shear wall. So, okay, let's go to maps and see the maps because this is kind of not very helping. So I'll just go to Z and click on maps. And let's take a look where the problems are. And from the get-go, I can see the problem here. So let's take a look here. Why is there a problem? This deflects heavily. The deflection seems to be coming from here. Of course, there are some X deflections here. We'll come to that. But first of all, we need to solve this issue. So why is there high deflection? Of course, I'm assuming that the loads are correct, and he calculated them perfectly. Now, this shouldn't deflect because there is a column. However, if this one, look, this is how we study deflection. You follow something called the load path. This shouldn't deflect that much because there is a column. Now, if it deflects that much, then the column has deflected. And you can see that the column continues deflecting until here. Here, there isn't much deflection. So there is something that happened to the load path, and I am thinking the column is discontinued. So let's take a look. So is that the case? Yes, that is the case. The column has been discontinued. But why? Now, if you want to discontinue a column, that's okay, but you need to strengthen the beams that carry the discontinued column. I don't know about the architectural drawings here, or what was actually intended to be done, but my immediate piece of advice for our dear engineer is to, hey, if you discontinue the column, then you need to provide strong beams, and if you want to continue the column all the way to the ground, then this problem will be solved. Okay, there is a discontinuous column. Why is this column discontinuous? I have problems with the structural drawing. I have massive problems here. You know what I will do? I will ignore this for now, and this column's, wait, is it discontinuous? Oh my god, everything is discontinuous here. So this column is discontinuous. This column is discontinuous. And it falls on this beam, which in turn is carried by those two columns. It's not carried by anything. That's pretty messed up. Okay, what's the point of all of this? Let me just understand what happens here. Okay, so you have a I need to go from down to top. So there is a column going here, and then you have everything being carried by nothing. Okay, that's a warning sign. I'm going to do something very stupid here. I'm going to go to my section, try something, just a dummy thing. So I would go here to 300, 500. I think it's a stiffness issue. Let me follow the load path. I am here. So this beam will carry me to this column, which carries me to this beam, which carries me to those columns, which carries me here, which is not continuous, which carries me here. Okay, let me just try something here, okay? I will do something ridiculously high stiffness just for the load path. So I want to try something here. This is, let's say here, big bad beam. And let's put something that is 1000 millimeter. I want to have something ridiculously stiff. Why is it in centimeter? Okay, fine. 30 by 100. I think because I used this file, now my entire robot is infected. I just modify this to 100 and add. So this is the load path. I will follow the load path and I will increase the stiffness of all the elements of the load path. I will ignore the instability because I know exactly what happened. I deleted some columns, but we are still here because, yeah, it's just a stiffness issue. So, okay, my verdict on this one is you have too many columns that are disconnected, and the reason why they are disconnected is something I don't know about. So there's a problem with the columns, and you need to add more columns or have some continuous ones. Don't keep planting columns on slabs because slabs are weak and cannot carry those loads that the columns carry. So that's a problem with it. Yeah, it's still problematic. I think my opinion on this one is you have multiple problems. The first problem is that your stiffness here is extremely bad, and the stiffness leads to increased deflection. Secondly, you have a very weak shear wall here. This will bend, and it has bent. There also a weak span here. That's why it's going down. And you can easily fix that by improving or increasing the number of columns. Like, look, let me show you how cool and easy it is. There are architectural considerations, but let me show you how easy it is. Like, look, this is the problem. Okay, fine. This seems to be the problem of the column. I'll take this column, which has the highest hopes of improving the system. I'll take it and I will extend it all the way down. The reason why I'm doing this, I want to remind you, is because I want to explain something by showing you how the load path plays a role in this thing. So let me just click here and delete. And now I'm going to add two supports here, which are pins. And now look at the difference once I run. And there you go. It has improved drastically. Now there is still a problem here. The stability of this one, the beams here are very weak. Of course, once again, I want to show you what I would do or what I would suggest as a solution for such problems. So let me just put the big beam here and this one here. Of course, those are ridiculously big, but I want to show you this one here and this one here. And I want to change the thickness of the wall because it keeps buckling. So I will check a thickness here and I will add me a new thickness of, I don't know, 50 centimeters, for example. I'll add that and close. And I modify this. There we go. Now, with that being said, I'm pretty sure that the deflection would be drastically better. Not perfect, but my point here is not to make perfection. My point here is to give feedback to my engineer who is working. Now, I could just tell him, hey, your load paths are all kinds of messy, but that's not good enough because I want to explain exactly how do I detect that, and I want to prove this to the viewers on YouTube, and that's the reason I'm doing it here. Okay, I think it drastically improved. Like there was a big black deflection here, it got better. The only big deflection you have is here. Wait, why do I have a big deflection here? This doesn't make any sense. You have 4 columns, don't you? Oh, that's telltale signs of a slab not being carried. The slab is not being carried, I think. Let me see. That's telltale signs of a slab being in midair. It's not in midair. That's very strange. What are you? Okay, is the column below it also? No, it's good. So why is this? Okay, this is very odd. Let's open the deflection to see. Ah, see? I told you, that's telltale signs of something not being carried. it is very obvious. Okay, that's a problem. So now this is a problem because of the beam is too weak here. And that's a problem because of being carried. The column is not carrying the beam. Okay, so let's fix that. Let's see. Yeah, there is the column. Now, of course, here this is not how you would do it. Of course not. I just do it for the sake of YouTube, just to show you how it's done. So yeah, you can see it very clearly. Those two dudes are not the same. So I'll try grab them. Let me just remove this entire stuff. Now I need to take this and put it here. So let me just click. I click on this once, and now I move it twice. So there we go. Will it even work? I don't know. So that's one thing. Okay. And now here we have a beam that was too weak. So of course I'm using my big bad beam here just to show you, but of course you don't use the big bad beam, you use something that is more sensible. So I don't know, I'll just put here a big bad beam, because that's a very big span, by the way. You could get away with the bad beam, by the way, because it is hidden in the wall. You can easily get away with such a big beam. Of course, this looks ridiculous. The only reason why I'm doing this is because I want to do this for demonstration purposes. So let's see. Anyway, I will run my final analysis for today and hope that it works. Okay, let's take a look. 53 millimeters. Okay, that's something I can live with. So, okay, let me recap the points of interest I have for him. First of all, you have some problems with your meshing systems. You are not aligning your walls perfectly. Secondly, you have too many cantilevers that kind of don't have any purpose except being cantilevers. And the beams there are very weak. Thirdly, your load path is extremely incorrect. The loads are not being carried all the way to the ground. Fourth point is, there are some inconsistencies in the meshing. For example, this column was unable to carry the slab because there was a misalignment, and this might be the case in multiple cases. And of course, finally, you have some stiffness issues that need solving. I don't know if you like those mumblings. It's the first time I do this. I don't think I will do it again, because it took me way more than I want to admit to have time for this. Yeah, I hope that you enjoyed this. Maybe you learned something new. I don't know. This is one of those videos where I don't teach something specifically, but I just give you a reflection of the models and how I usually attempt to check the model, checking the assumptions, checking this mesh, discussing why the mesh is messed up, and so on. And I hope that you enjoyed it. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a perfectly aligned sliced shout out to my channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank you from the bottom of my heart, as the support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.